And welcome once again to my new calculus channel. So in a previous video, I asked the question, what was the motivation behind Hipparchus's chord tables? And like I said, I was going to answer it. So here is the answer. Now, much has been written about Hipparchus's chord table and how he used it. But the key question is, why did Hipparchus choose this approach? There is a simple one-line answer to this question, but the screeds of drivel written in many mainstream mathematics textbooks and in so many other places on the internet clearly exposes the fact that no mainstream mathematics professor or teacher knows the correct answer. So, ChatGPT says Hipparchus created chord tables to calculate linear distances corresponding to angles on the celestial sphere, essential for precise astronomical observations and predictions. Wikipedia Moronica says he tabulated values for the chord function. MacTutor says the purpose, and this is the funniest of the lot, the purpose of this table of chords was to give a method for solving triangles. What on earth does solving triangles mean? Even mean? Which avoided solving each triangle from first principles. Wow, that's quite fascinating because I bet you not even professors understand this. What does solving each triangle from first principles mean? And then he also introduced the division of circle into 360 degrees. So I gave ChatGPT a multiple choice test. A. Hipparchus wanted to have a means of identifying angles. B. Hipparchus wanted to perform astronomical calculations. C. Hipparchus wanted to develop trigonometry to help in calculations, and he wasn't sure how to measure angles in any other way. Well, turns out that all of these are actually true, but only one is the correct answer. So I gave ChatGPT 2 tries and eventually it chose A because it directly addresses the core reason behind Hipparchus's creation of chord tables. Identifying and working with angles was essential for his astronomical calculations. While the other options are related, A is the most fundamental, as the identification and measurement of angles were necessary before any calculations or development of trigonometry could take place. Okay? Now, a moronic mainstream mathematics professor's answer would reflect that of Wikipedia Moronica. In fact, Wikipedia Moronica is infested with mainstream mathematics professors and their lackeys who are totally devoid of clarity and understanding. Whilst Wikipedia talks a lot about measurement, it misses the forest for the trees. The main goal of Hipparchus was to identify the angles, first geometrically and then algebraically. Pay attention to that, math professors, because you're the biggest morons out. Since the radii of circles are different, a chord will only be meaningful when associated with a particular radius. That is, it can be used in geometric arithmetic without numbers. Why would Hipparchus need a table of values? Well, simply this, because those who used to build uh, monuments and constructions in those days didn't know anything about mathematics and much less about numbers. So they needed some kind of guidance, and they could only get it with respect to geometry. In other words, a chord related to a particular radius. Okay? The main idea, and of course, you can learn more about this in my fantastic article, Arithmetic Without Numbers, and also watch the video inside that article. The main idea was to easily associate an angle with a certain line segment after which it could be used in conjunction with the right angle ratios to find out the distances and angles. After all, one can't mix angle measure and line segment measure. Pay attention, Professor Jack Azinger. I know at one time you thought that you could use Newton's sine function with radians and degrees. I hope you've grown a lot wiser now. You can't mix these two indiscriminately because they're different types of objects. Thus, if a circle has a blue radius and a red half-chord, as you see in this diagram, then the angle is defined geometrically by the blue and red ratio. So how is it defined geometrically? Well, this is the angle that you see here. So let's go to GeoGebra. So what Hipparchus did was he took this chord and said, given any angle, right, any angle, you could place this point at the center like that, and then just do this, okay? And basically, you can identify that angle. It doesn't matter what angle you use, okay? It doesn't matter if it's a straight line or he could identify up to all angles from 0 to 180, and then the rest could be done through trigonometric identities, right? You see that? So if you wanted to get this one, well, there you go. Does that make sense? Right. So algebraically, the angle is defined as an approximation using numbers which uniquely identifies the half angle at the center, as I showed you in here. Okay. Uniquely identifies this half angle, either this half angle or this one. And this value corresponds approximately to the sine of 48.18 degrees, which is approximately 0.74536. Now, Hipparchus could identify any angle exactly in geometry. Compare this with algebra, where most angles can only be approximated because modern mathematics defines an angle as the measure of this ratio. Okay, in geometry, we use this ratio in geometric arithmetic with 100% accuracy. We can't do that. Here's the ratio. We can't do that in algebra. Okay, in algebra, we have only an approximation. Algebra is a weaker form of geometry, you morons, that uses an abstract unit rather than a physical unit. Most math professors need a semester course to understand this. But if you're not a math professor or teacher, you'll get this right away. And the measure in algebra, or the identity of the angle in algebra, is the approximate measure of this geometric ratio, okay, as I'll show you here. So this is what algebra does. It tries to measure this with this, the blue segment with the red segment. That's how Hipparchus got his tables. That's kind of ironic, isn't it? Because mainstream mathematics academia believe falsely that the ancient Greeks didn't have algebra. Well, they're all utter baboons, aren't they? So, and ultimately, how does this relate to the sine function? Well, the chord is equal to 2 times the radius multiplied by the sine of the half angle. So you would take this red line over this blue line and multiply it by 2 times the radius to get the length of this entire chord. And that is basically, in a nutshell, in a very powerful explanation, what Hipparchus's methods were about. Now, I'll place a link to this article, but before I sign off, if you're not already a subscriber to my channel, become one and follow me on academia. Furthermore, click on join on my video so that you can see knowledge which I do not share or have not shared at all with the public. And I will be sharing once I start producing videos for my members only channel. Okay, so what you need to do there is you need to join. It's a €5 per month, but you'll learn more than any of your dumb university professors can teach you, because they're absolute morons compared to my intelligence. If you take an ape and a human, the difference between them and me is the same as between an ape and a human. I being the human and they the apes. So be sure to join my members only channel. Click like, as I've just done here, because there are many assholes who get on here and post negative comments and downvote my videos. Whereas I am the best mathematics lecturer and educator ever. And I am a career threat to them because I would fire a lot of them. They're not they're not mathematicians even. They like to think they're mathematicians, but they're worth less than asswipes. Very well then. I'm the great John Gabriel, and this is the New Calculus channel. Till next time, goodbye.